Hey, my name is Aniruddha Kalburgi, and I've worked along with Josed and Abdullah to talk about a major discipline as mechanical engineering. So this video basically talks about the grand challenges that mechanical engineering is facing, and also the sub-disciplines that we are allotted to talk about. So now let's go. We interviewed a professor, and let's go into that video.
I'm Dr. Carl Barrett, Professor of Mechanical Engineering, Coordinator of the ME program here at UNH. And the question is, what is mechanical engineering? It's a very diversified field. In mechanical engineering, you study thermodynamics and fluid dynamics and heat transfer, as well as basic Newtonian dynamics. And mechanical engineers can go into all sorts of fields. Some of them go into pre-law, for example. They can become patent examiners. Medical school is encouraging engineers and physicists and all scientists to go into medical school nowadays. They like the way engineers think. They like the way physicists think. Yeah, it's just a diversified field. If you want to get involved with renewable energy, solve the great challenges, build better power plants or send men and women to Mars and so on, mechanical engineering is the field to be in. Because you'll be working, and you'll also need to work with electrical engineers, of course, and industrial engineers, but the grand challenges that you're going to be solving in your lifetime will draw heavily on the sort of skills that you develop in mechanical engineering. Do you not agree?
Yeah.
Yeah? Okay, they agree. All right, next question.
What do you think the duties and responsibilities of a mechanical engineer is?
The duties and responsibilities of a professor of mechanical engineering, or our duty and responsibility is to teach you mechanical engineering, and more important than just teaching you knowledge is to develop skills, the communication skills, which of course we have with the pitch projects and the spiral curriculum, and you've got to learn to work with other disciplines and so on. These are the skills that mechanical engineers should be learning. So I guess that's my responsibility as a mechanical engineering professor, to help nurture the skills as well as teach you all about the first and second laws of thermodynamics.
And last question is...
last question only?
Yeah.
All right. Being a professor of mechanical engineering is different from what you'll be doing when you go out into the real world, right? Unless you two become a professor as well, right? The life of a mechanical engineer should be fulfilling. I mean, you're solving grand challenges. They're probably paying you pretty well. Although you can look forward to probably having 5 or 6 or 7 or 8 different jobs in your lifetime. Don't count on a lot of security. But if you develop the skills, then you'll be well set to have a very fulfilling life, solving some very foreboding, challenging problems that face this world, starting with climate change. As a mechanical engineer, you should be thinking, how can I solve the climate change problem? Oh, renewable energy, right? Go invent a better fuel cell, a cheaper fuel cell, right? So I trust that I think most mechanical engineers out there in the real world have very fulfilling careers. But, it's certainly better than being tied to a desk adding up numbers all day long, right?
Yeah.
Hi, my name is Joseph Rivera, and the sub-discipline I've chosen for mechanical engineering would be the HVAC system. HVAC stands for heating, ventilation, and AC system. The first one would be heating. To my left, you're going to see an example of a heating system where the air is being heated at a central furnace and being sent out into the building through vents and pipes. Next is ventilation. A ventilation system is used to circulate the air in a given space, which controls the indoor air quality. In the simulation below, you will see the relationship between the supply and return vent and how air is circulated and recycled. Last would be air conditioning systems. Air conditioning systems are usually used to control the ventilation, humidity, and temperature in a building and vehicle. There are many jobs all over the United States that are hiring HVAC systems at the moment. For instance, cyber coders in California California are hiring HVAC engineers at the moment, and also BMCP in New York. The average salary of an HVAC engineer would be $75,000.
The subdiscipline that I'm going to talk about is automotive systems. So automotive systems is a branch of mechanical engineering which deals with systems such as transmission systems or steering systems, etc. Automotive systems is used in day-to-day transportation, so anything related to transportation components or like on which the transportation runs on is of automotive systems. For example, it will be such as, like I said, the engine is from automotive systems. The braking, which is so essential for any transportation, is a part of automotive systems. As I mentioned before, automotive system engineers are basically required to work around cars or engines or transmission systems. And companies that are presently hiring automotive system engineering are General Motors, Toyota, and Honda. And the median salary or average salary that companies do offer automotive engineers earn is around $70,000, which as you get more experience, you probably earn around $105,000.
Mechanical system engineer work as a member of the system and control engineering team. The primary responsibility will be to develop a control system. The average of this position is $73,000.
Yeah, basically otherwise.
Well, you could start off by passing 107P, right? And you just got to work on the basic skills, you know, the teamwork, the communication, and learn your force balance diagrams and so on, and do your basic circuit analysis, and just develop a work ethic, you know, putting in the hours and so on, you know, at least 2 or 3 hours out of class for every hour in class. Practicing. I encourage students to form constructive study groups as well. You've got to know what constructive means versus destructive, of course, and you can ask your professor about that. The difference between a constructive and a destructive study group. You just got to work hard, play hard, work even harder, and you'll graduate with good grades, and you'll get a good job, and you'll get reasonable pay, and you might even solve a few of the world's problems in the process. So, I hope the advice was somewhat useful. Okay?
Thank you.